Hello, this is Bohao. Today we're going to solve problems with given forces. So here is the question. The force of gravity on a basketball is 16 newtons downward. And the first question is asking about the net force on the ball while holding stationary in your hand, which means the basketball is constant. Now, it's not moving. In that case, with a constant condition, the F-net should be 0 newtons. And we move on for question B. So it says, we do not need to care about area resistance, and we need to calculate the net force acting on the ball if you suddenly remove your hand. So in that case, there's no more Fnet, Fn, which give him support. So at that time, the ball only applies the force that is gravity. So it should be only gravity acting on the ball, which is 60 newtons downward. And this third question said you push the ball with the force of 12 newtons, right? And you'll be asked to calculate the net force on the ball. In this case, we draw a free body diagram and we can see that we can redraw this 12 newtons, right? And we have a net force which is pointing at a few angles downward, and the when the x-axis velocity newtons should be 12 newtons to the right, and the y-axis forces are only 16 newtons, which is gravity. So let's calculate for this net force. After gathering the forces on x-axis and y-axis, what we're doing now is calculating square root bracket 16 square plus 12 square. And we have 20 newtons, which is the net force. And we need to calculate the angle. The angle is equal to theta equals to tangent to the power of -1 bracket 16 over 12, which equals to 53 degrees. In that case, the net force should be 20 newtons from the right, 53 degrees downward. And we are solving question D now. It says you are pushing the ball with a force of 26 newtons up 45 degrees right, and you are being asked to calculate the net force. So in that case, we first draw a free body diagram with gravity applied and the force that you've been pushed. And we analyze the force on the x-axis and the y-axis, which is separately 18.4 newtons and 2.4 newtons. While you add F for y-axis, you add F gravity and Fy1 for this applied force. You add them together and only find out there's only 2.4 newtons upward. So therefore, we can calculate Fn with the equation square root of bracket 18.4 square plus 2.4 square newtons, and we have 18.5 newtons. Then we need to calculate the angle. Angle is equal to theta equals to tangent to the power of -1 bracket 2.4 newtons over 18.4 newtons, which equals to 7.4 newtons. And we had this final answer. So this net force should be 18.5 newtons, right, 7.4 degrees up. And we are done for the question. Thank you.